Hi everyone, my name is Miss Connolly. I started making videos for students in my own class, but thought that I wanted everybody to learn math at this crazy time, so now I'm making videos for all of you. Students, teachers, parents, if you have a topic you want me to cover, connollymathathome@gmail.com. Make sure you share with a friend, share with another teacher, share with a parent. Let's get as many students learning during this time as possible. And this video is really special to me because I'm making it for the 4th graders at my school, and I'm hoping it benefits any 4th grader out there. But I just want you to know I'm so excited to be doing division with you, and I can't wait to do even more division with you in the fall. Okay, so let's get started. We're going to be thinking about 4 digits. 1, 2, 3, 4, divided by 1 digit. I love it. So what we're going to do is we're going to give our division situation a story problem context. We always want to have a story problem so we can make sense of all these numbers. So what we're going to think about is 2,538 oranges. That's a lot of oranges. We are going to be dividing them into 6 crates. Okay, so a crate is a ginormous box that you can put oranges in or other stuff. And then I want us thinking about how many oranges are going to be in each crate. That's what our answer is going to be. That's what our quotient is in this situation. Quotient, that's what we get when we divide. So, again, I have 2,538 oranges. I am going to split them into 6 equal groups, and I want to know how many oranges are in each group. So, let's get started. I've set this up over here, and I want to just point something out because some kids, they call this like the 7 method. It's not the 7 method, everybody. Today I'm going to go over the strategy, one strategy at a time here, of multiplying up. So we're going to use multiplication with the groups of the divisor. And this number is the divisor. This is not the only way to notate this strategy. This is the way that I'm going to show it now. I'm going to let you try it at home. I'm going to make more videos with more strategies. Okay, I'm also going to be showing you how this strategy looks on the area model, which you're very familiar with for multiplication, and I'm going to help you make the connection with division. Okay, so again, is this the only way to divide? No. Is it the only way to record this strategy? Also no. Okay, but is this what I'm showing in this one video? Yes. All right, so 2,538 divided by 6. When you were dividing 3-digit numbers by 1-digit numbers, you were thinking about, I'm going to start with something like 6 times 10 or 6 times 20. We can't do that. Well, we could. It would just take a really long time. We're not going to do that when we're starting with 2,538 oranges. Okay, but we are going to be thinking about something very similar. We're going to be thinking about multiplying up, starting with multiples of 100. And eventually, you might be thinking about multiples of 1,000. But let's stay where we are right now. We're going to be thinking about multiples of 100. Okay? So, something you know. 6 times 1. So, since you know that, you know 6 times 100. Okay? Something you also know. 6 times 2. Which is 12. So, if this factor gets 100 times larger, so does my product. Okay? So, we have to decide which multiple of 100 we want to start with. And how do we decide? Well, that is something. So, 2,538. If I started with 6 groups of 100, so I did 100 oranges in each of the 6 crates, I would use 600 oranges. I think you might be thinking, Miss Conley, if we start there, we're going to have to do that a lot of times. Okay, there's several groups of 600 that are going to fit in 2,538. Could we start there? Yes. Is it a little extra work? Yes. So we want to choose which multiple of 100 that we want to start with that's closest to using 2,538 oranges. Okay? So if I did 300 oranges in each of the 6 crates, I would use 1,800 oranges. If I did 6 groups of 400 oranges, I would use 2,400 oranges. And if I did 6 groups of 500 oranges, that would be 3,000 oranges. Now, This doesn't have to be happening on your paper. It's happening up here, and you're thinking about where's the best place to start. If you want it on your paper, go for it, but keep it way off to the side so we don't have a lot of numbers confusing us, okay? So let's come back. When I'm thinking about this, I want to get closest to 2,538 as I can. So I know that these down here are a little bit further, and I have these two to choose from, okay? So when I'm thinking about 6 times 400, that means that I would be putting 400 oranges in each of 6 crates, and I'm using 2,400 oranges. And I know that if I have 6 crates and I put 500 in each, I'm using 3,000 oranges. Something in my brain is saying, wait a minute, we don't have 3,000 oranges. So could we start there? No. So this is how I'm choosing where to start. That's how you should be choosing where to start. So what I'm going to do is I'm going to erase all this extra stuff so we can stay focused. I'm going to draw 1 crate to show you what's going on. I am going to take those 6 crates. I'm going to do 6 groups of 400 oranges, which is using 2,400 oranges. So I put 400 in each crate. So there would be 6 of these, but I don't have that much space, so we're going to just draw 1. So far, I have put 400 oranges in each crate. I have used 2,400 oranges, so I need to figure out how many oranges I have left. So I'm going to, oops, and sometimes I make mistakes, you'll find out if you end up in my class next year. So now we have 138 oranges left. Phew. I'm out of the hundreds. I know that I am done with multiples of 100 because 6 times 100 is 600, and I don't have 600 oranges left. So we're back in a place where we feel comfortable if this is something we're familiar with because we've done 3 digit by 1 digit. So I ask myself, what multiple of 10 could I use in each crate to get close to 138? So I know 6 groups of 10 would be 60 oranges. So I could put 10 in each crate and that would use 60 oranges. Or I'm thinking if I put 20 oranges in each crate, that would be 120 oranges. And that gets me closer to 138. So I'm going to put 20 oranges in each crate. If I do that in 6 crates, that means I've used 120 oranges. So I take my 120 and I subtract from the oranges I have left. I had 138 oranges. I'm taking away 120 because they're all in crates now. And I'm left with 18 oranges. It's a beautiful thing when we get here because now we know, and some of you might be saying, oh, I know what to do. I know that I have 18 oranges, and if I had to split 18 into 6 equal groups, I know that I would put 3 oranges in each group. I'll use all of the 18 oranges that are left, and I'll be left with 0 oranges. Oranges, this is where we keep track of how many oranges we have. So, there goes my next group of oranges in the crate. First, I put 400 oranges in each crate. Then, I put 20 oranges in each crate. And I used 120 oranges at that step. And then, I took my remaining 18 oranges. I put 3 in each of 6 crates. And I used all 18. And I have 0 oranges left over. Okay, so how many oranges are in each crate? Well, first I put 400, then I put 20, then I put 3. You see it? In your strategy, if you notate it this way, remember there's more than one way, you see 400 plus 20 plus 3, you see it over here. So there is 423 oranges in each crate. Okay? So now I'm going to show you what that would look like on the area model. Okay? I'm going to keep my crate down here. And we are going to think about the area model that you're familiar with for multiplication, and I'm going to show you what you're given right now and how you can use this to represent what's happening with division. So, you have been given the area here, 2,538. Oops, that's a 6. You have been given one dimension of the area model. So you're used to seeing length times width and you write the area. But you have the area, let's say you're given the length, which is 6, and you have to figure out what is this dimension here. Okay? So I'm going to use what we did in multiplying up. I'm going to show you what it looks like on the area model. Okay? So if you picture this, I'm just going to draw the rows here. This is 6 crates. Okay? So 1, 2, 3, 4, 5, 6. There's 6 crates. We know on the inside, this needs to represent, this whole entire thing needs to represent 2,538 oranges. So let's say that you're going to put 400 oranges in each of the 6 crates. Okay? So I just drew these little ones here. I would go all the way across. You're going to put 400 here, 400 here, 400 here, 400 here, 400, 400. You're going to put all of that inside here. Do you see how I'm taking 6 crates, 400 in each? What I can do in the area model is, instead of doing 400, 400, 400, 400, I can say 6 groups of 400, and I'm going to have to make this work, is 2,400 oranges. So I know if this entire area has to equal 2,538, I know that this piece over here is going to be 138. So you see that I'm keeping track of my area in here. I know that this is going to represent my quotient. Okay, so if I take the 2,538, I divide it by 6. The other dimension is where we're going to find our answer when we're representing with the area model. Okay, so and I showed you that it would be 400, 400, 400, 400, 400, like we were putting 400 oranges in each crate. But the efficient way to show that is to write 2,400 here. So 6 times 400 is 2,400. That's the area of this piece. Then we thought about multiplying 6 times 20. So if I labeled this part of the width 20, and I said that this piece represented 120 of the oranges, so we have 6 as the height, 20 as the width. This piece here, the area of this rectangle here would be 120, and so what's left over is 18. So you ask yourself, 6 is the dimension here. What would be the width if the area was 18? And you know the only number that fits there is 3. So we see where the 423 would be our answer when we're representing multiplying up with groups of the divisor with the area model. Okay, so it's kind of exciting that you're used to figuring out what's the space inside because you're given the length times the width. But when we're dividing, we're telling you what the area is. And we're telling you what the length is. And your goal is to find the width. Okay? So, while you're working today, I want you to be trying to have an area model representation as you're multiplying up. So, I'm going to do one more example. I'm going to show both of them at the same time. Okay? We're going to be thinking about 1,824 divided by 4. Okay? Again, not attaching anything. This is not the 7 method. It is multiplying up with groups of the divisor. I am going to also show you how this is happening, or what's happening over here on the area model at the same time. Okay, so again, we have 1,824 oranges. We're putting them into 4 crates. How many oranges in each crate? Okay, so just like last time, we're going to move it a little quicker this time. I want to think about what can I multiply 4 by to get as close as possible to 1,824 oranges. I'm going to start with multiples of 100. So 4 times 100, 400. Kind of hard. That would be a lot of steps. 4 times 200, 800. 4 times 300, well, I know 4 times 3 is 12, so I know 4 times 300 is 1,200. I'm saying I'm getting closer. I'm telling myself, okay, try one more. 4 times 4 is 16, so 4 times 400 is 1,600 or 1,600. And I'm just going to double check. 4 times 5 is 20. So 4 times 200, sorry, 4 times 5 is 20. So 4 times 500, sorry about that, is 2,000. I don't have 2,000 oranges, so I know where I'm going to start, and that is going to be with 4 times 100. Sorry, 4 times 400 is where I decided I would start, because when I was counting, 4 times 400 got me closest to 1,824 without going over. Okay, so 4 times 400, made my area model too big, is 1,600. I thought about 4 times 4. My factor got 100 times larger, so my product gets 100 times larger. Okay? I am taking my 4 crates. I'm putting 400 oranges in each one. I'm using 1,600 oranges. So, I say to myself, how many oranges do I still have left that need to be put into the crates? I subtract the oranges that I've used, and I'm left with 224. So what does that look like in the area model? Well, I'm going to do it actually down here where there's a lot of room. I had 1,824. I said I'm going to put 400 in each of the 4 crates, and I know that this piece is going to equal 1,600. If I put 400 in each of 4 crates, I'm going to use 1,600 oranges. And what's left is 224. Okay, so I still see the 1,824 over here in this representation. I'm still trying to figure out how many more oranges I can put in each crate. Okay? Okay, so I'm at 224 oranges. I know that I can't make 4 groups of 100 because that's 400. I don't have enough oranges left. So I go down to my multiples of 10. So I'm thinking 4 times 10 is 40, 4 times 20 is 80, 4 times 30 is 120. I'm getting closer. 4 times 40 is 160. 4 times 50, 200. I think that works. And 4 times 60 is 240. Too high. So I say to myself, the next thing I'm going to do in each crate is put 50 oranges. Okay? I know that that will use 200 oranges. So I'm going to take the 200 oranges that I'm using. I am going to subtract them because they're in crates already. And I am left with 24 oranges. What does that look like on your area model? I said that now I have 4 crates. That's the height, the length. I'm going to put 50 in each crate. and that uses 200. Okay, so I see 1,600 plus 200, which is 1,800. And I know that in my area model, there's 24 left. Okay, I still have to sort out. So you see our answer starting to develop here, the quotient, and you see our quotient start to develop here. We're thinking about how many oranges are in each crate. First I put 400, then I put 50. So far, there's 415 oranges in each crate, and I'm left with 24 oranges that I still need to split between the 4 crates. Okay, so I'm sure you're thinking at home, I know this one. So what we're left with is 4 groups of, and you're thinking about 4 times what makes 24. I'm going to put 6, I'm sad about my marker. I'm going to put 6 oranges in each of those 4 crates, which means that I've used the last 24 oranges. There's 0 oranges left over. We're thinking about all of this as how many oranges we have left to distribute. And I put 6 more oranges in each crate. So you should be thinking about how many oranges are in each crate, because that's where our answer is going to be. So again, on the area model, what happened is your length was 4. This piece of the area model was worth 24 oranges. So I'm thinking, how many did I put in each crate? What's the width of this piece? And it's 6. So, where is our answer in this strategy? We did 400 in each crate, then we did 50 in each crate, then we did 6 in each crate. We used all of the oranges because there's none left over. So in each crate there was 456 oranges, and that's where we see our answer in that strategy. And then when we're representing with the area model, we had 1,824 oranges. We were splitting them into groups of 4. And how many oranges went in each group? We see our answer here, 456. Okay, so I'm going to give you 3 problems. You're going to work on this strategy and try representing it with the area model. And then in the next video, we'll go over another way to think about these problems. So you are going to be thinking about 1,350 divided by 6. You are going to be thinking about 1,540 oranges divided by 4. And you are going to be thinking about 2,156 oranges divided into 7 equal groups. Okay? Keep track of how many oranges you're putting into each crate, because that's where you're going to find your quotient. That's where you're going to find your answer in the strategy. Okay? Bye.